NPU in AI. Here is your same structured, beginner-friendly content. For NPU, Neural Processing Unit, in AI, Beginner Level Introduction. A NPU, Neural Processing Unit, is a specialized processor designed to run AI models efficiently on devices, especially for real-time and edge AI applications. Unlike CPUs means general tasks, GPUs means parallel tasks, TPUs means large-scale AI. NPUs are built for on-device AI processing, low power consumption, real-time performance. They are commonly found in smartphones, smart cameras, IoT devices, edge AI systems. Examples include
Face recognition on phones, voice assistance, camera AI features,
real-time translation. This topic helps beginners understand how NPUs bring AI directly to devices. What is an NPU? A Neural Processing Unit, NPU, is a processor optimized for running neural network operations efficiently on device. In simple words, NPU equals a chip designed to run AI on your device. Key idea: instead of X sending data to cloud, NPU does process AI locally, reduce latency, improve privacy, save power. NPU versus CPU versus GPU versus TPU. Feature: NPU, GPU, TPU, CPU. Purpose: edge AI, parallel computing, large AI tasks, general computing. Location: device, mobile edge, device cloud, cloud data centers, everywhere. Speed AI, fast, real-time, high, very high, low. Power usage, very low, moderate, high, moderate. Face.jpg. Print: recognizing face locally. Example of real-time processing. Voice equals hello. If voice, print, voice command processed instantly. Simple NPU concept example. Python. Def detect object. Data. Print, detect object image. How NPU works. Step 1, capture input. Input data equals camera image. Step 2, run AI model. Print, running model on NPU. Step 3, process quickly. Result equals object detected. Step 4, output result. Print result. Act in real time. Print action taken instantly. NPU in smartphones. Task equals face. Unlock. Print, unlocking phone. NPU in voice assistance command equals play music. Print, processing command locally. NPU in camera AI scene equals night. Print, enhancing image. NPU in IoT devices, sensor equals motion. Print, detecting movement. NPU in autonomous systems, object detected equals true. If object detected, print, avoid obstacle. Advantages of NPU: low latency, high efficiency, privacy protection, real-time processing, reduced cloud dependency. Full menu-based NPU example: def, detect face. Print, face detected using NPU. Def process voice. Print, voice command processed. Def enhance image. Print, image enhanced. While true, print, number 1, detect face. Print, number 2, process voice. Print, number 3, enhance image. Choice equals input, enter choice. If choice equals 1, detect face. Elif choice equals 2, process voice. Elif choice equals 3, enhance image. Elif choice equals 4, break, else, print, invalid choice. Edge AI, on-device processing, real-time AI, low-power computing, neural network acceleration, AI hardware. Real-life analogy: NPU is like a smart assistant inside your device. Fast, private, always available. Ways to improve a project: use mobile AI frameworks, build edge AI applications, optimize models for devices, use TensorFlow Lite, use OnNX runtime, test real-time performance, reduce model size, explore hardware APIs. Common mistakes beginners make: not sending all data to cloud, not optimizing for edge devices, not ignoring latency, using heavy models, not considering power usage. Where it is used: smartphones, IoT devices, smart cameras, wearables, robotics, autonomous systems, smart homes, healthcare devices. Large systems may include edge AI platforms, mobile AI chips, real-time AI systems, embedded AI, simple definition, NPU, neural processing unit, a specialized processor designed to run AI models efficiently on devices in real time. Final summary: NPUs enable: click fast on-device AI, click real-time processing, click privacy protection, click efficient edge computing. They are essential for bringing AI closer to users and devices